next thing we're going to look at is what to do when we have a fraction within a fraction. So remember that a fraction divided by a fraction just means divide. So that means fraction divided by fraction, which means we can multiply by the reciprocal as long as our denominator is one fraction. And I'll explain kind of more about what that means as I go through some examples. If we don't have one fraction in the denominator, oftentimes we're going to clear fractions, and we can do that by multiplying both top and bottom by a least common denominator. So let's go ahead and look at and start by looking at example 1. In example 1, notice I have a fraction over a fraction. My bottom fraction is simply one fraction, so all I'm going to do is say I understand that this means divide, and I'm going to say this can be rewritten as 3 over 2 divided by 1 over 5, and I know that when I divide with fractions, that's the same thing as saying times the reciprocal of the second. Nothing to cancel, so I multiply straight across, and I get 15 over 2 as my final answer. The second example is looking a little bit more complex. Notice now, if I look at my denominator, it's not one fraction. I have two fractions being added together. So what I'm going to do is I'm going to get rid of all these extra little fractions within this one large fraction by multiplying both top and bottom of my larger fraction by the least common denominator of all of my little fractions. So if I look at all my little fractions here, and I try to find a least common denominator for each of them, very similar to what we did in the previous, in one of our previous objectives, is I'm going to look at each denominator and I'm going to make sure I have every denominator's components. So for my first denominator, I take a 2x. For my second denominator, I've already taken the 2, so I take a y. And then looking at the bottom, I've already have the x in my least common denominator, and I already have the 2y. So I'm going to go ahead and say, I'm going to multiply this whole top by 2xy, and this whole bottom by 2xy. And doing so won't change my fraction at all, since I'm doing the same thing to top and bottom. I'm essentially multiplying the whole fraction by 1. Doing that, it's going to distribute in on top, giving me 2xy over 2x minus, and I'm going to not multiply the 3 and 2 together for now. I will, and you should see y after. 2xy over 2y all over 2 times 2xy. Same thing, I'm holding off on multiplying those together, plus 3 times 2xy all over 2y. So right now you may be looking at your notes or looking at your screen and saying, that just made it look a lot worse, but look, my 2's cancel, my x's cancel, my 2's cancel, my y's cancel. That's why I wanted to wait to multiply these together, because I was anticipating that some things were going to cancel. My x's cancel, my 2's cancel, and my y's cancel. So why does that help me? Well, look at what my new fraction becomes. My new fraction becomes y minus 3x all over 4y plus 3x. And that's it. There is nothing else I can simplify, because remember, I cannot simplify with adding and subtracting, so I cannot cancel these y's and I cannot cancel these 3x's. This is my final answer. And I know this is simplest form because, as I just mentioned, nothing cancels. I don't have any like terms I can combine. And notice I only now have one fraction as opposed to having multiple fractions within. Let's look at one more example like this. Notice this one's even more complex yet. So first thing I notice is I cannot simply flip and multiply, because again, like the last example, I do not have a single fraction in the bottom. I have an expression in the bottom. So I'm going to go ahead and I'm going to clear my fractions by getting a least common denominator. So again, my least common denominator I'm going to take from all of them. So I'm going to take an x plus 1. I'm going to take a 3x. I've already taken then the x, and I'm going to take an x minus 1. And I'm going to multiply this entire fraction by this least common denominator. When I do, it's going to distribute into the top. Well, actually, let me go ahead and actually write this instead of trying to pull from up here. Alright, so I'll multiply this whole top by x plus 1, 3x, x minus 1, and I'll do the same thing to the whole bottom. And it will distribute in to both terms on top as well as to both terms on the bottom. So on top I will have 3 times x plus 1 times x minus 1 times 3x minus 4 times x plus 1 times x minus 1 times 3x and on the bottom 2 times x plus 1 times x minus 1 times 3x and again, at first it looks more complicated, but as I go through and see, there are quite a few things that I can cancel. Not quite as nice as the last one in terms of canceling. I'm still going to have quite a bit of work I have to do here, but nonetheless some things canceled out, leaving me with on top 9x times x minus 1 for my first fraction. I went ahead and I multiplied the 3 and the 3x. Minus 4. I'm going to anticipate I'm going to combine like terms anyway, so I'm going to start multiplying some things together. So x plus 1 times x minus 1 are conjugates, so I'm going to get x squared minus 1. Same thing here with this fraction. So I'll have, and I'm going to multiply the 2 and the 3 together. So I will have 6 times x squared minus 1, again those same conjugates appearing, plus 5x minus 1 times 5x plus 1. I'm going to go ahead and FOIL that, giving me minus x squared plus 4x plus 5. And I still have that 3x in back. And then finally distributing the 9x. Well, I guess not finally because then I'm going to have to combine like terms. I distribute a minus 4x in. Don't forget that minus sign. Distributing the 6 and distributing in the 3x. And then lastly, I'm going to go ahead and combine my like terms. And I get on top 5x squared minus 9x plus 4 all over negative 3x cubed plus 18x squared plus 15x minus 6. So, big thing with clearing fractions, what do I need to remember? I need to remember that if it is single fraction over single fraction, I can go ahead and flip and multiply the second fraction. If not, I'm going to go ahead and get rid of my my so-called little fractions by multiplying top and bottom of my entire fraction by the least common denominator of all my little fractions. Make sure you bring in any questions you have on this video into class so we can get them cleared up.